Hello, hello. Can you hear me? Hello.
Hello.
Yeah. Okay. So we'll continue with number theory. In the last class, I gave you a few problems, right? A few
Yeah,
questions.
yeah.
What was the first one?
The first one was with the digits from 0 to 9, each digit being used exactly once, we form
Hmm,
two five-digit numbers m and n. Find the largest m such that m is equal to 7n.
second. Right. Okay. We have to use digits from 0 to 9, each digit only once. Each digit only once. And we have to make two five-digit numbers M and N,
Yeah,
such that M is equal to 7N, and we need to make the largest possible M.
yes.
Okay, so what have you thought here?
Um, for that one, what I did is that so in general, the largest number, five-digit number you can make is sorry, 98765. And if you divide that by seven, you get 14109. And then the smallest number you could make is 10234. And if you multiply that by seven, you get 71638. So then M has to be
How do
between
you
nine.
how do you know the largest number you can make? What are you?
Sorry,
How did
not
you
the
get
largest.
that?
Oh, just because there's distinct digits, so then the largest five-digit number in general that you could make is 98765.
Hmm. Yeah, so M, the maximum possible value with distinct digits is this.
Yeah,
Now, if M is less than equal to this, then 7N is less than equal to this, right?
yes,
So from here, we can say N will be less than equal to divide by 7. So this will be
like one.
14,109.
Yeah, yes.
Okay. Now, now what?
And then I just like did the same thing. So the smallest number you could make is 10234. And then if you multiply that by seven, you get 71638. So then M has to be greater than or equal to 71638. And
Why are
then,
you doing smallest number? We don't care about smallest, right?
oh, right. Yeah. I was kind of stuck from where to go on with here, though.
We don't care about smallest numbers and all. We just have
Yeah,
to figure out M.
right.
You have to have N less than this, but
Right.
here there are two ones,
Right.
and
Yeah.
we can't use this number because there are two ones. We need to make sure that we start off not with 141. So
Right. Yeah.
something smaller than this then obviously n has to start with 140, right?
Yeah.
N has to be less than this, but we can't use 141. So obviously we'll have to start with 140, right?
Yes.
If m is if n is starting with 140, then obviously it will be greater than this 14,000. We can't even use this because this has repetitions, right?
Yeah.
Even if you start with 140, you have to have different numbers here and here for n, right?
Right.
That means n will be greater than 14,000 for sure.
Yes.
It is less than 14109, but it is greater than 14,000. Correct?
Right.
So that means m, which is 7n, is greater than 98,000
Right.
because n is greater than 14,000, right?
Yes.
Okay. Now, if m is greater than 98,000, then m starts with 98.
Yeah.
Okay. By the way, when we are saying two 5-digit numbers m and n have to be formed, we have to use the digits 0 through 9. That means
Yes.
actually the digits 0 through 9 will be used for 5 of them for this, 5 of them for this.
Right. Yeah.
If I already know m is greater than 98, that 98 cannot be used in n. Do you understand what I'm saying?
Yeah.
So what are the things we can't use? We know that n has 140, so we can't use 140 here.
Right.
We can't use 98 here, right?
Mm-hmm.
So now, if you can't use 98 there, then the biggest possible number you can make here n could be, let's say, 14076.
Yeah.
Those are the largest possible n. If you make n large, then you'll make m also large, right? Basically, in order to make the largest possible m, you need to make the n also as large as possible.
Yeah.
So 140 was fixed. After that, we put 7 and 6, right?
Right.
M will be 7 times this, which is 98532. Now, 98532 uses all different digits. It doesn't use digits from here. So now
Yes.
this satisfies every condition. We have used each digit once. M is 7n, and beyond this, we can't make it bigger. Because 140 was fixed, so 76 is the largest possible thing.
Yes.
Do you understand what I'm saying? Is it clear what happened here? Your answer will be 98532 for M.
Yeah.
Okay. What is the next question?
The next question is find all 5-digit numbers that are equal to 45 times the product of their digits.
Hmm. Okay. Equal to 45 times the product of their digits. So you can call the number n as A, B, C, D, E. Okay. Now we need to make sure that this is 45 times the product of A, B, C, D, E. Right? You are on mute. I can't hear you. What have you tried here in this question? Hello, are you there?
Yeah.
What have you tried in this question?
So for this one, I said that, okay, so first we know that E has to be 5 because, like,
Why?
uh, it has to be 5 because it's a multiple of 45, which means 5 is a factor. And since we have to multiply 45 by the product, the last digit can't be 0, so it has to be 5.
Why can't the last stage be zero?
Because then everything multiplies to 0. So then the product won't work out to be equal to the number.
What do you mean everything multiplies to zero?
Because it's saying that find all 5-digit numbers that are equal to 45 times of the product of their digits. So then if 0 is one of the, then that product is, and then multiply, it's never going to equal the 5-digit number.
Hmm.
So then the last digit has to be 5. So
Okay.
then we so then we get like 45 times A times B times C times D times 5 is equal to 1,000, sorry, not 1,000, 10,000 A plus 1,000 B plus 100 C plus 10 D plus 5. And then we can divide that whole like equation by 5 to get 45 A, B, C, D is equal to 2,000 A plus 200 B plus 20 C plus 20 D plus 1. Sorry, 20 C plus 2 D plus 1. And then to be a multiple of 5, 2D plus 1 has to equal, like, 2D plus 1 has to equal some multiple of 5 because 2,000 in it. So,
These are not divisible by 5.
yeah. So then 2D plus 1 has to equal some 5. So then you get that D has to either be 2 or D can be 7. But then if D is like, if D is 2, then when you multiply it, you get 5 times in the digits, you get 5 times 2 is 10, and that'll make whatever number you get end with a 0. So then you're never going to get your 5-digit number that ends with 5, so D can't be 2. So that means D has to be 7. So we put that in and you get that 45 A, B, C, D is equal to 2000 A plus 200 B plus 20 C plus 15. And then you can divide that by 5 to get 9 A, B, C, D. 9 A, B, C, D is equal to 9 A, B, C, D is equal to like 400 A plus 40 B plus 4 C plus 3. Yeah,
Can divide by 5 here
yes.
and you will get 408 plus 40b plus 4c plus 3 is equal to 63 ABC.
Yeah.
Okay, then what?
And then here I was kind of stuck because I don't see any common like factors that you could like take out.
We have right hand side is divisible by 9.
Yeah, but like 440 and 4, like those aren't. So,
We can make it 396A plus 4A plus 36B plus 4B plus 4C plus 3. 396 and 36 are divisible by 9. So what you have left is 4A plus 4B plus 4C plus 3.
right.
Obviously, this part is divisible by 9, so this part also has to be divisible by 9.
Yeah, correct.
Now we can say that 4 times A plus B plus C plus 3 is divisible by 9, which means this is some, let's say 9K. So we have 4 times A plus B plus C plus 3 is equal to 9K. So um, let's think what we can figure out from here. So we can write it as 4 times A plus B plus C minus 6 plus 9 is divisible by 9. So we know that this part is divisible by 9, right?
Yeah.
So um, A plus B plus C is coming as 9K plus 6, something like that. 4 times A plus B plus C is equal to 9K plus 6. So we have to figure out what are the possible, anyway, we have to figure out what are the possible values of this. You can write it like this also from here. What are the possible values of A plus B plus C? So we know that since these are digits, this
Hmm.
ranges from 3 to 27. Anyway, we know that.
Yeah.
And we can check which values will fit this condition, that it is 9K minus 3. So putting K is equal to 1, you get 6. K is equal to 2, you get 15. K is equal to 3, you get 24. And K is equal to 4 is becoming bigger than 27. So
Yeah.
obviously 4 times A plus B plus C cannot be 6. Then it can't be 15, it has to be 24. 1 second, can it be 15? 9K minus 3. We can say 24. We are getting A plus B plus C is 6.
Yeah.
1 second. 9K minus 3. 9K minus 3. Um, 1. Right. So what I'm saying seems correct only. So the only possible value of A plus B plus C is 6,
Right.
because A plus B plus C cannot be anything else. Otherwise, this plus 3 basically I'm saying a plus b plus 4 times a plus b plus c has to be 24.
Yes.
Okay, so now we get a third condition. Now we can use that and use that, for example, here and say a plus b plus c is 6, right?
Yes.
So 4 times this is 24 here and plus the 27 here.
Mm-hmm.
And we are getting 396a plus 36b plus 27 is equal to 63 ABC. You can
Right.
cancel 9 and you'll get 44 and 4 and 3 is 7 ABC. 44a
Right.
plus 4b plus 3. Okay. And now you can do the same thing. Ultimately, we are doing the same thing every time. We are saying this part is divisible by 7 now. We have
Yeah.
been doing the same thing from the beginning when we had ABCDE. We started with divisibility by 5, then we looked at divisibility by 9. Now we are going to look at divisibility by 7, right?
Yes.
So the way to simplify it is always these terms you can try to make it 42a plus 2a plus b plus 4b plus 3, right?
Yeah.
We'll say this is divisible by 7 now, correct?
Yes.
2a plus 4b plus 3 is divisible by 7, so 7k. And from here, you can say 2 times a plus 2b is equal to 7k minus 3, right?
Yes.
So a plus 2b, so 7k minus 3. Okay, so a plus 2b, what is the maximum value or minimum value? You can have goes from 3 up to goes to 2 into 9, 18 plus 27, right? Maximum. You can have 9 any number of times. There's no restriction on that, right? So it goes up to 27 again, right? A plus 2b.
Yeah.
Okay, so twice of that will go from 6 to 54. And we have to see which numbers in this range are in the form of 7k minus 3, right? 7k minus 3, if you start off with, it starts with 4, then you
Yeah.
get 11, 11, then you get basically 18, and so on. You get every time multiple of 7 minus 3. So 25. So, okay, so you'll have to check many cases. So you have to think of something more. Uh, A plus 2b has to be between 3 and 27. What else can we say? Uh, we can also try. Uh, can we say something about even and odd stuff? Uh, we know, I think, that the number earlier only we knew, I think, when we had the initial equation that one of the digits was 5. You cannot have a digit 2 then, right?
Yeah.
Right. You cannot have any digits 2, 4 and all, right? Because that
Because it's
makes the number divisible by 0 or ending in 0, right?
right.
If it ends in 0, the question doesn't work. So we know that ABC was odd and all, right?
Yes.
So that is an important piece of information. ABC are odd digits, right?
Right. Yeah.
That we know from before only because they can't have 2, 4, 6 and all, right?
Yes.
So A plus 2B would be also odd, right?
Right. Yeah.
A plus 2B would be an odd number. Now that means 2A plus 4B is 7K minus 3. So 2A plus 4B will be even. Okay. So 7K minus 3, and we can now restrict it to even ones. So 25, 32, 39, 46, 53. So we can remove all the odd numbers here, right? And we are stuck with now only these options, right?
Yeah.
Okay, so these are the possibilities of 2 times A plus 4B, 2 times A plus 2B. So A plus 2B in these cases are 2, 9, 16, and 23, right?
Yes.
2 won't work. A plus 2B is not possible, right? A plus 2B is 9. That is a possibility. A plus 2B is 9, 16, 23. 16 would it work? All even, all odd digits. Okay, so A plus 2B is odd, so that can't work 16, right?
Yeah.
9 and 23 now is our thing. So we can say that 9, what are the options in which we can make a 9? We can say B is 3, A is 3, right? A is 3, B is 3, correct?
Yeah.
23, how can we make? A is, B is 5, 10, no, that doesn't work. So B has to be 7, 14, 9 and 7, right? 7
Yes.
and 9. No, no, 9 and 7. Correct? Right. A and B can be
Yes.
9 and 7. Okay. 7 and 7, does it work? No. Okay, so A and B is coming from here. 9 and 7 is one option. 3 and 3 is another option. Right?
Yes.
Once we know this, then you can go back in the previous equations and find C and see what C is going to fit here, right?
Yeah.
And then you have to rework your steps before in the previous steps and find each of the, using all the equations we have seen so far, you have to go back. Do you understand what I'm saying?
Yes.
Ultimately, it's a question of divisibility and checking the range of numbers and realizing that ABC, the digits cannot be even, right?
Yes.
The even odd part helps us reduce the number of cases, correct?
Yes.
To finish the problem, try to finish it. What was the next question?
The next question was find the digits x is not equal to 0, y, and z so that xyz, the number, is equal to x factorial plus y factorial plus z factorial.
X is not equal to 0. Y and Z are some digits. You have
Yeah.
to satisfy this condition.
Yes.
Okay.
So what I did is that, so when we just think about it, x, y, and z, they all have to be less than or equal to 5, because if suppose x was 6, well, 6 factorial is 720, so that already makes the sum greater than the number itself. So none of those numbers can be 6, and the
Wait,
smallest,
what? Why?
like like x, y, and z have to be less than or equal to 5.
Why?
Because if any one of those numbers was 6, let's say x was 6, then 6 factorial is 720, but then the number would start with 6. So then it's not possible. And then 7
Why can't
factorial,
Y be 6?
well, because then it's still 720, and 7 factorial,
Mm-hmm.
so then the number is going to be like greater than 720, but 7 factorial and higher is greater than 3 digits. So it can't be that.
Okay.
So I got that all those numbers have to be less than equal to 5. And then I just took cases. So let's say x is equal to 5. Well, that's not possible, because then if we make all the numbers 5, the highest sum you're going to get out of the factorials is 120 times 3, which is 360. So that's not possible. If x is equal to 4, it's still not
Wait.
possible.
Why is it not possible for 360?
No, I'm saying it's not possible for x to be equal to 5.
Why?
Because then if we take the greatest number you can make, 555, out of what we've already said, all the numbers have to be less than equal to 5. Well, 5 factorial plus 5 factorial plus 5 factorial is 360.
Mm-hmm. So,
So then x can't be equal to 5 or 4. Then we look at
no,
3.
1 second. Can you stop leaping to judgment?
Oh, sorry.
What is the logic? 5
Like,
factor, it is adding up to 360. What is the problem?
because then the number you're making is 555, but then the addition of the factorial is 360, so it's not equal.
So who said that all three have to be equal to 5?
Because that's the greatest one you can make if you can't use 6, and then
Why
the
are you
rest are
trying
just,
to make the greatest one?
no,
You,
just to see if it'll work, having 5 as x.
what do you mean just to see it will work? Like we can keep other digits here, right? What is the problem? Why can't we
Yeah,
have a number with different digits and this sum is equal to it?
well, if you we're just taking the greatest one to see if it'll actually like be a number that is going to equal something in the 500s, because if you take 543, which is less than 555, that number is going to be less than the sum of those factorials is less than 360, which still won't work. So we can just say that the number won't be in the
Why does the
500.
first digit have to be 5? It could be this digit is 5 and this is 300 something.
I know, that's why I'm taking cases. I then do x is equal to 4, that still doesn't work. X is equal to 3, that still doesn't work, and so on and so on. I do it. I'm taking cases. I haven't gotten to the 300s yet.
Okay.
So then I keep on taking cases like that, and then I get that the number is 145, because I got that x is equal to 1, and then if y is 4 and z is 5, then it equals.
How many cases did you take?
So I took one for x equals 5, I took one for x equals 4, x equals 3, x equals 2, and x equals 1.
The answer is correct. 145 is the answer.
Yeah.
What was the next question?
The next one was find all positive integers n such that each digit of n squared minus 3 is 3.
Mhm. Okay, what have you done here?
So for this one, I wasn't really sure how to go about it. Like I got one of the answers, like because it's an obvious answer. I got that n must be 6 because n squared is 36 and then minus 3 is 33. And we know that like n squared minus 3 has to be like 3 or 3 3 or 3 3 3 and so on. But I didn't really know how to like go about it in like a number theory mathematical kind of way to like make cases or like kind of add limits so that we're not just going like 3 3 3 3 and like testing everything out.
You have to, if you have gotten one solution, you have to prove that there are no other solutions. One solution is clearly n is equal to 6.
Yeah.
We have to think of how to show that there cannot be any such numbers if you are saying that that's the only answer. If you have let n satisfy this condition, in that case, if n square minus 3 has at least 4 digits, if n square minus 3 has at least 4 digits, then the last 4 digits, then last 4 digits of n square have to be 3336. Then only when you subtract 3 from it, it will become 3333, right?
Yeah.
Now 3336 has to be the last 4 digits at least. If the n square minus 3 has at least 4 digits. Now
Right.
3336 is, if you think of the factorization of this, it is divisible by 8, which is 8 into, you will get 4 and 1 7. So this is 8 into 417, so it is divisible by 8 but not divisible by 16.
Yeah.
Now that means n square is also divisible by 8 because this is the last 4 digits are divisible by 8. So n square is divisible by 8, but it is not divisible by 16 because last 4 digits are not divisible by 16. So you have failed the 16's divisibility criteria.
Yeah.
We have seen earlier that if you have 2 power n or 5 power n, the divisibility criteria is last n digits have to be divisible by 16,
Right.
or last 10 digits have to be divisible by 5 or
Yeah.
5 square or 20 whatever. To check divisibility by 25, we check last 2 digits. To check divisibility by 125, you'll have to check last 3 digits and so on, right?
Right.
Here, you can say that n square number is divisible by 8 because last 3 digits are divisible by 8, right?
Yes.
But it is not divisible by 16 because last 4 digits are not divisible by 16.
Right.
Okay, now that means this is wrong. This can't happen because any n can be written as the n could have been written as 2 power something into some odd number, right? Where m is odd. And when you do n square, it will become 2 power 2s into m square, right?
Yeah.
So it has to be divisible by an even power of 2, not a odd power of 2. N square will be divisible by an even power of 2, right?
Right.
It can't be like n square is divisible by an odd power of 2. That doesn't make any sense. Do you understand what I'm saying?
Yes.
If you think of n, any number that is even, it will have some 2 power s and some odd number, right?
Yeah.
So n square has to be divisible by always by an odd even power of 2.
Yeah.
So that means this itself is not going, it's a contradiction here. If we get that n square is not divisible by 16, but divisible by 8,
Right.
right?
Yeah.
That means our some assumption is wrong. For example, the assumption was here. Number of digits of n square minus 3 was greater than or equal to 4. Then we said that last 4 digits have to be this, right?
Yeah.
This assumption itself is not going to be incorrect now because we are getting a contradiction here.
Right.
We are getting n square is divisible by 8 but not 16, which is not possible.
Right.
So if we have gotten a contradiction here, that means number of digits of n square is less than 4.
Yeah.
Digits of n square minus 3 less than or equal to 3, right?
Yeah.
So if it has at most 3 digits, now the number of cases to check are very few. You can say that n square minus 3 is 333 or n square minus 3 is 33.
Yeah.
This doesn't work. This works, gives us the answer. There's no other case to check.
Oh, okay. Yeah.
You have to basically prove that it can't work for more than that digits.
Yes.
The proof is that if you try with 4 or more digits, the last 4 digits of n square have to be this to fulfill the condition of the problem, that each
Right.
digit has to be 3, right? As soon as you get 3336 as the last 4 digits, that automatically means that number is not divisible by 16. But it also means that it is divisible by 8, correct?
Yeah.
Okay, so as soon as you get that, now you have a contradiction because n, if n was some even number also, what we will have is n will be some 2 power s into m and n square will be divisible by 2 power 2s and all.
Yeah.
Is it clear what we have done?
Yes.
Was there any other question?
No, that was it.
Okay. Let's try out this problem. Let a be a positive integer and such that a power n has an odd number of digits for all n greater than equal to 1. Prove that a is a power of 100. A is a positive integer such that a power n has an odd number of digits for all n greater than equal to 1. Okay. So if that is a condition, technically this condition means many things, many results. So for example, it means that a power 1 has an odd number of digits, right?
Yeah.
So basically, if it is an odd number of digits, either it is between, it's a single digit number or a 3-digit number, right?
Right.
Or a 5-digit number and things like that. So we can say, what can we say about A? We can say that it will lie between 10 to the power 2k to 10 to the power 2k plus 1, right? Where k can be starting from 0 and all. K is
Yes.
greater than equal to 0.
Mm-hmm.
Because if you put 0, you'll get 1 to 10. Then after that, it will be 100 to 1000. If you put 100 is less than equal to A, less than equal to, it will be 1000. So here we can't make it equal. We have to be less than that, right?
Yes.
It can be 3-digit, it can't be 1000, it can't be 4-digit.
Right.
This side is equality also is there, this side there is no equality. K can be greater than 0 anything. Now it will always be odd number of digits now.
Yeah.
So that is the first thing that we know. Now, what can we say about A square? A square also has an odd number of digits, right?
Yes.
So we already know that A lies between this and this. So A square will lie between 10 power 4k less than A square less than 10 power 4k plus 2, right?
Right.
So how many digits does A square have?
5.
What do you mean 5?
Like,
If some number is between 10 power 4k and 10 power 4k plus 2, it has 5 digits.
oh no, sorry. It'll have
10 power 4k is 1 followed by how many zeros?
4K.
4k.
Yeah, 4K zeros.
That number is already going to have 4k plus 1 digits.
Yeah.
So the possibilities, this is 4k plus 1 digit number, right?
Mm-hmm.
It's less than 4k plus 2 means less than 4k plus 3 digits.
Yes.
So basically it can have 4k plus 1 digits or 4k plus 2 digits, right?
Yes.
Can't be equal to this, so can't have this many digits.
Right.
So from here you can say that A square has either 4k plus 1 or 4k plus 2 digits,
Right.
right?
Yes.
Similarly, you can think again for A cube. A cube will be between 10 power 6k and 10 power 6k plus um, 3, right?
Yes.
No, 6k plus 2, a cube would be power 3 here. No, it will be 6k plus 3 here. So the number
Yeah.
of digits for a cube will be 6k plus 1 and 6k plus 2 again, right?
Yeah.
Same logic, exactly same thing. Correct?
Yeah.
Okay. Uh, Basically, now you have a pattern here, and you can say similarly, a power n will be between 10 power 2 and k, and less than equal to a power n is less than 10 power 2 and k plus 1, right?
Right.
And that means that, like, it's the same pattern that we are getting every time. No, 1 second. Before we go to this step, so far what we have concluded is, okay, so far what we had was 10 power 4k is less than equal to a square less than 10 power 4k plus 2. And from here we got that a square has either 4k plus 1 or 4k plus 2 digits, right?
Right.
But in the question itself, they had said that a power n has odd number of digits, right?
Right.
So we have to obviously exclude this case, right? Because this is an even number of digits.
Right. Yeah.
We have to exclude this case, which means we don't have this, and we can say a square should be between 10 power 4k less than a square less than 10 power 4k plus 1. Can't have 4k plus 2 digits.
Right.
So how did we get to here? We started off with saying that A has to have how many digits? A has to have basically odd number of digits, and therefore it should always lie between 10 power 2k and 10 power 2k plus 1, right?
Yeah. Right.
Because we had that for A, we squared it and got this. From where we got this, and we have to exclude this because of the initial hypothesis the question itself was saying. Because this will
Yes.
make A square have even digits. So we exclude that and we refine the inequality, make it stronger by saying that now A square has to be restricted between these two, right?
Right. Yeah.
From the A inequality, that A was between 10 power 2k less than A square less than equal less than 10 power 2k plus 1. From here, cubing it, we get 10 power 6k less than equal to A cube less than 10 power 6k plus 3, right?
Yes.
So again, A cube can have 6k plus 1, 6k plus 2 from here, but we'll reject the 6k plus 2 case, right?
Yes.
A cube can have these many digits, we'll reject this digit because it will make it even digits. So again, we can say A cube will have 6k plus 1 digits only. So that means it will be between 10 power 6k is less than A cube less than 10 power 6k plus 1, right?
Yeah.
Now we are getting a pattern. Every time A square is between 10 power 4k and 4k plus 1, A cube is between 10 power 6k and 6k plus 1.
Right.
And now we can extend and generalize it. You can do the proof by induction, and you can say that 10 power 2 and k is less than a power n less than 10 power 2 n k plus 1.
Yeah. Okay.
For all n greater than 1, this is going to be true if it has to satisfy the conditions of the problem. Right?
Yes.
So the question is asking that a is a power of 100, we have to prove. We have 10 power 2 n k is less than equal to a power n less than 10 power 2 n k plus 1. Now we can divide by 10 and 10 power 2n on both sides, and we will get basically divide by this whole thing. We'll get 1 is less than equal to a power n by 10 power 2 n k is less than, this will be 10, right?
Yeah.
So from here we can say a power n by 100 power n, 100 power k whole power n, right? This is 10 power 2k
Yeah.
only. So we can say 1 is less than equal to a by 100 power k whole power n is less than 10, right?
Yeah.
If this thing has to be less than 10, this result has to be true for all n greater than equal to 1, right? The question was true for, this was true for all n greater than equal to 1. So we are saying all of these steps are true for all n greater than equal to 1. So now, like there are two cases. This number can be less than 1 or greater than 1, right?
Right. Yeah.
There are three cases. It can also be equal to 1. You can prove that if it is less than 1, it will automatically violate this condition. If this thing is less than 1, the fraction, then automatically it cannot be greater than 1 when you raise it to power n. Do you understand what I'm saying?
Yes.
Is it clear what I'm saying, that it can't be less than 1?
Yes. Yes.
If it was greater than 1, then this inequality can't be true always for all n. Because if it was 1.1 also, there will come a time when the n will make it bigger than 10.
Yeah.
Because even if it is 1.01, you will take large enough n, then the whole power will become bigger than 10. It cannot always stay under 10, right?
Yes.
Do you understand what I'm saying right now?
Yeah, I understand.
So both the cases there is something wrong. It can't be less than 1, the fraction can't be greater than 1, because then this inequality will not be true always. So only possibility is it is equal to 1, then it is always true, right?
Yeah.
So then that proves that a must be equal to 100 power k, right?
Right. Yes.
And that makes it a multiple of 100. The main argument here is, if we get to this stage was the main idea, where using the hypothesis that a always has an odd number of digits and a power n also has an odd number of digits, we construct all the cases, we check how many digits are there, we got to this step, and that must be true for all n greater than 1, right?
Yes.
As soon as you get to this step, after that, you can divide by this and get an inequality like this, which only makes sense if a is equal to 100 per k. It doesn't make sense in any other case, right?
Yes. Right.
Okay. The next thing that we'll be doing is division algorithm. So next week onwards, it will be theory. We have to learn some theory first, and then we'll do more problems. So division algorithm, congruences are the next topic. So just read up on that if you can, and then we'll continue from here. Also, like you have to work on the three papers, try to solve as many of the questions as possible, the ANC papers, for the next
Right.
class.
Yeah. Yeah, I'm doing those papers.
Right. Okay. We'll continue from this point next week then.
Yep.
Okay. Bye.
Oh, are there no like homework problems?
No, not for now, because next week will be theory for number theory.
Oh, okay. All right.
Hmm.
Thank you.
Hmm.